Welcome to a day in the life of the Niagara River Lake Erie Watershed. Every year, hundreds of students and educators join forces with local environmental professionals to collect water quality data from around the watershed, providing a snapshot of our watershed health. We know that the Niagara River Lake Erie watershed is an area of land where all of the water drains into Lake Erie and the Niagara River. Runoff water flows over that landscape, carrying with it sediment, nutrients, litter, and other pollutants. We look at 7 major indicators to see if those pollutants are affecting water quality. We may find warmer temperatures in our fresh water if shade-providing trees have been removed from streams or riverbanks. Sediment can also make the water darker and absorb more sunlight. There may be industrial discharge releasing warmer water, and finally, runoff from warm pavement can increase water temperatures. We often look at water temperatures in combination with dissolved oxygen because cooler water can hold more oxygen. Dissolved oxygen is also affected by the amount of photosynthesis of aquatic plants. Oxygen can also dissolve in the water from the atmosphere, and fast-moving water crashing over our rocks and boulders takes in more oxygen. It's harder for oxygen to dissolve in water that has a lot of salts or other dissolved or suspended solids. We get a better idea for the level of suspended solids in the water through our transparency test. Using a turbidity tube, we see how far light can travel through a tube of water. If the water is very cloudy with sediment, bacteria, aquatic organisms, or algae, it could indicate problems with erosion, urban runoff, or wastewater. High turbidity, measured in centimeters, or low turbidity NTU units are preferred. Agricultural and urban runoff, as well as wastewater overflow, could add more nutrients to the water, so we also measure nitrate levels. Nitrate is a form of nitrogen that easily dissolves in water. pH measurements show us where our water falls on an acid-base scale. Ideally, we would like a measurement of 6.5 to 10 out of the range of 14. Water can become more acidic, indicated by a lower pH with acid rainfall, which is caused by pollution in the atmosphere. It can increase in the presence of detergents and soap-based products found in wastewater. pH is also influenced by types of soil and bedrock, so we want to make sure to look at other indicators when determining if our water has been impacted. This spring, we started looking to see if our road salt is impacting our fresh waterways, and we'll have those results soon. Everyone's favorite measurement is looking at what is living in the water. We collect macroinvertebrates, animals without a backbone, such as insects, crayfish, and leeches. Some of these animals can only survive in very clean, cold water, so their presence or the lack thereof can be an indicator of how clean the water is. Let's dive in. We know our water is moving from areas of high elevation down toward Lake Erie and the Niagara River. Runoff is collected along the way, so we should have the best water quality at our headwaters, the source of our major tributaries. For each field study site, you will see our data results shown in the white circles. Our temperature is shown in degrees Celsius, our dissolved oxygen in parts per million, higher usually is preferred. Our transparency is shown in centimeters, so high transparency in this situation indicates better water quality. Nitrate is also shown in parts per million. We would like this number to be low for good water quality. Our pH target range is between 6.5 and 9 for good water quality. And finally, our macroinvertebrates. There's a few different ways to measure our macroinvertebrates. Today, we're going to be looking at percent EPT. E stands for Ephemeroptera, which are mayflies. P stands for Plecoptera, which are stoneflies, and T stands for Trichoptera, which are caddisflies. And so these species usually require clean water in order to survive. And so high percentage indicates good water quality. Let's start at Spraguebrook County Park near the headwaters of Cazenovia Creek. This was one of our last stops during the 2020 Day in the Life event. Today, we'll just look at the raw data. Tomorrow, we'll dive into the analysis of what it all means. Hi, everyone. I am ending our day here at Spraguebrook County Park, sampling at the headwaters of Cazenovia Creek. And oh, what a beautiful evening it is. This small little tributary to our tributary Cazenovia is a beautiful little stream. If you haven't been out here before, I encourage you to come out. what I'm most excited to show you is the macroinvertebrates that we have been collecting this afternoon. So macroinvertebrates can be an indicator of water quality, along with the things that you might think to sample for, like we've been talking about: dissolved oxygen, nitrates, pH, etc. And the macroinvertebrates that we found here at Sprague Brook are incredible. They are indicators that this stream has pretty great water quality. So let me show you what we found. All right, so here we have our little collecting tray of macroinvertebrates. Over here we have more stoneflies than I could even collect in the net. And stoneflies need very cold water with high oxygen levels, usually an indicator of very clean water. So we found so many of those. Found lots of little caddisflies here squirming around. We found multiple different kinds of mayflies. Their nicknames: we have our flat-headed mayflies and our minnow mayflies here. Mayflies also need very clean water to survive. Oftentimes are a great indicator of good water quality. We have maybe a little bit of an attack going on down here with one of our fly larvae. Looks like maybe a crane fly larva crossed into where we were holding our damsel flies. So if you've ever seen those, they look like dragonflies, but they're thin and they hold their wings back. As adults, this is what they look like as their nymphs right there. And then finally, we have our dragonfly nymphs right here. They can live in the stream for some species for more than a year before emerging out as adults. So really beautiful find here this evening, showing that Sprague Brook Park here has some great water quality. Thank you to Erie County Parks for always supporting this event and allowing our students to sample at multiple parks throughout the county. Let's travel down south to the headwaters of Canadaway Creek near Fredonia, New York. Hi everyone, today is Monday, October 5th, and today I'm sampling at Canadaway Creek Wildlife Management Area down near Fredonia and Dunkirk, New York. I have the little Canadaway Creek flowing right past me here, and if you were to look at an aerial view of this area, it would be just forested all around this creek. So the land use, how people are using the land, is very different than, say, where our friends at Buffalo Niagara Waterkeeper are sampling today up along the Buffalo River. So it will be very interesting to compare these two sites today along the Buffalo River and down here in a little bit more southern western New York along the Canadaway Creek. Both because of the difference in size, the difference in land use, and then the geographical difference too. So some things that we're finding today: Canadaway Creek has very high oxygen levels, above 12 parts per million. It also has no nitrate levels that we could detect, so very low, if any at all. And it reminds me a lot of where we were sampling at Sprague Brook County Park in the headwaters of Cazenovia Creek. But the creatures that we're finding here today are a little different than what we were finding at Sprague Brook. So I'll give you a closer look at those. So here you see one of the creatures we found in a slow-moving area of the stream, and we're going to use our chart here to see if we can identify it. So to do that, what we'll do is we'll put our collecting container in the middle of each circle and see if it resembles the creatures on the outside. Now, it doesn't resemble our dragonflies because it has these kind of almost spiky things coming off the side, so we'll move it over to the next one. Trichoptera or caddisflies often build houses around them, so it's not carrying any of that, and again, none of those spiky things. So we'll move over here, and you can see it fits very well in our order Megaloptera, which includes both alderflies and our closest match here, the Dobson fly. And you can see that our Dobson fly has some pretty large mouth parts. We want to be a little careful when we handle our Dobson fly. It can pinch us with those mouth parts, but that is our closest match. This is one that we found crawling on a rock, And to help me identify this one, I'm going to look at the tails. I can see that this one has 3 tails, and so I can use the bottom part of our sheet here where we see our organisms with tails. If we look over at the odonta or damselflies, it looks very similar, but damselfly tails are a little bit wider and they tend to hold them in almost a triangle shape. Our stoneflies only have 2 tails. So this must belong to our mayflies or Ephemeroptera, which means short-lived. This nymph might live for a few months underwater, but when it's ready to become an adult, it's going to come up to the surface of the water, crack out of its exoskeleton, and emerge with wings. The adults, however, do not have mouth parts, and so they only live long enough to mate, lay eggs, and die. So short-lived, short life as an adult, usually less than 24 hours. We actually found an adult for one of our other mayfly species over here, and I'll show it to you. Floating on top of the water there. We'll head to a more developed area next, Buffalo Creek at the Birchfield Nature and Art Center in West Seneca. Students from the West Seneca Christian School sampled here in 2020. And at this site, we found some higher dissolved oxygen levels, but our transparency was a little bit lower, and you can see some sediment in the stream flowing around our students in this video. Our nitrate levels were also a little elevated at 0.44 parts per million, and our macroinvertebrate percentage was much lower. Only 8% of the organisms we found were our mayflies, stoneflies, and caddisflies, our Ephemeroptera, Plecoptera, and Trichoptera. Buffalo Creek flows downhill into the Buffalo River, so we'll head to Mutual Riverfront Park next. I'm here this afternoon at Mutual Riverfront Park in Buffalo with the Buffalo River flowing right behind me. This park really shows the legacy as well as the future of this area of our watershed. The Buffalo River is defined by its historic legacy, the legacy of pollution. But also, we are now at a park where people, while I've been here, have been launching kayaks to go explore our water body. So we're really in this transition period thanks to some wonderful community partners who help us out with this program as well. Partners like Erie County, as well as Buffalo Niagara Waterkeeper, have done fantastic work along this Great Lakes area of concern along the Buffalo River. So, while it's very exciting, we also notice a few differences up in this part of the watershed. So, for example, our nitrate levels were elevated here. Our dissolved oxygen levels were slightly lower here than they were in our tributaries earlier this morning. We also found different organisms. Let me give you a look at what they look like. So here at Mutual Riverfront Park, we're finding things like leeches and snails and freshwater mussels. Very different than the mayflies and caddisflies we were finding in our tributaries. But this is a success story too. It wasn't that long ago that the Buffalo River was declared dead, and now we have life in the river and we have people using the river. A true success story. Our final stop is along the last stretch of the Niagara River. Students from Stella Niagara Education Park walked across the road to sample the river water at the Stella Niagara Preserve, and here they found low dissolved oxygen, some elevated nitrate levels, and none of those key macroinvertebrate species, leaving us with 0% EPT. What a journey! We only looked at a few of the sites we sampled in 2020. Join us tomorrow to look at the full picture as we analyze the data from all 21 sites.